Systems of linear equations in two variables. So what we're talking about here is a system where we have two equations and two variables. And hopefully you've already studied these in a previous class, and you understand that there are three possible types of solutions for such a system. One is no solutions, and that occurs when the two equations represent parallel lines distinctly, distinct parallel lines, that is, two parallel lines that are different from each other. Since they don't intersect, there are no solutions. We also have the possibility of having one unique solution, a single point in the xy or Cartesian plane, and that is when the two equations represent lines that intersect in exactly one point. And our third possibility is an infinite number of solutions, and that's when the two equations represent exactly the same line, and therefore all points on the line satisfy both equations, and we have an infinite number of points on the line, so we have an infinite number of solutions. Something that's maybe different from the way you've looked at these types of systems in the past is that when you run across that situation where there are an infinite number of solutions, you're going to be asked in this course to write a parametric solution. And we're not going to go through a parametric solution as part of this video, but I do want you to be aware that that is something that you should be looking into and you should be learning how to do. Let's look at example 1, where we're asked to solve the given system of linear equations. And in this case, we're given 2x plus 3y is equal to 16, and x minus 5y is equal to negative 5. To solve this using the intersection capability on the calculator, we're going to need to solve both of these equations for y. That is, we're going to need to put them into slope-intercept form. So let's take these two equations and let's copy them. And once I have them copied, I'm going to paste them. And then I'm going to see about editing them. And what I'll try to do on the screen is go through the process here that one goes through to solve for y for both of these equations. So we'll wait for my equation editor program to come up here. All right. And it's still thinking. All right. Oops. So taking a look at the first equation here, the first thing we're going to want to do is subtract 2x from both sides. So when we subtract 2x from the left-hand side, we're going to lose that 2x. So I'm going to delete it. And I'm also going to delete this plus in front of the 3y. And then I'm going to put the negative 2x in front of the 16. So in subtracting 2x from both sides, we remove 2x from the left, and we end up with a negative 2x on the right. All right, here we go. Negative 2x plus 16. And then we need to divide everything by 3. So I'm going to divide both sides by 3 so I get just a single y. So this 3 here is going to disappear. And I'm going to end up with a fraction, negative 2/3 x. And I'm going to end up with a fraction here, 16/3. All right, so there's the first equation turned into slope-intercept form. Now let's do the same thing with the second equation. The first thing we're going to do is subtract an x from both sides. So the x will disappear on the left, and we will end up with minus x minus 5 on the right-hand side. And then we're going to need to divide everything by negative 5. So I'm going to remove the 5 and the negative. And that's going to change the sign of everything on the left. So we're going to end up with a fraction here of 1/5, and it's going to be positive because we had negative x divided by negative 5. And we're going to end up with just a plus 1 here. All right. So let's go back to our problem here. And we see that if we change these two equations, we get y is equal to negative 2/3 x plus 16/3, and y is equal to 1/5 x plus 1. These are not parallel lines because the slopes are not the same, and therefore these lines, the system of equations, excuse me, must have one unique solution. It cannot have no solutions, and it cannot have infinitely many solutions because the slopes are not the same. All right, so let's go over to our calculator, and let's go into our y equals screen, and let's type in these two equations. So I'm going to type in negative, and then in parentheses, I'm going to, just being careful again, order of operations, to put the 2/3, and then x, and that's going to be plus, and I can put the 16/3 in parentheses or not here at the end, depending whether I feel like it or not, and I'm not going to. And that's going to be, for the second equation, 1/5 x, and to that we're going to add 1. And I'll enter that. All right, now we need to graph it. For a couple of simple linear equations like this, it's often a good idea to start with the standard graphing window. So I'm going to press zoom and choose option 6 for Z standard or zoom standard. And the calculator is going to go about graphing these two lines. It'll graph negative 2/3 x plus 16/3 first. And we see that coming in here. From the left going to the right, it is decreasing, which is what we expect with a slope of negative 2/3. And the slope 16/3 is a little bit more than 5, and that's what it looks like it's doing, is the y-intercept being just a little bit more than 5 there, 16/3. All right, our positive slope for the second equation of 1/5 tells us we should be increasing as we go from left to right, and we should have a y-intercept at about 0 and 1, which is right there what we see. So there is our intersection. We can see it just fine here, so we can now go to the calc menu, and we can choose option 5 for intersection. And the calculator is going to ask us those questions we've talked about in earlier videos. First curve, well, y1 is one of the two curves. Second curve, y2 is the other curve. And then it wants a guess, so I'm going to cursor over and get fairly close to where that intersection is visually. The better the guess is, the quicker the calculator can solve the system and solve for that intersection. So let me work my way over there, slowly as usual on my slow computer calculator. And that looks pretty good right there. So I'm going to press enter, and the calculator is going to come back and tell me the intersection is at the point 5 and 2. And we can check that. If we look back to the original system of equations, 2 times 5 is 10, 3 times 2 is 6, and if we add them together we get 16. Or if we take 5 and subtract 5 times 2 or subtract 10, we'll get negative 5. So those both check, they make sense, and there is our solution. Now let's take a look at example 2. We're asked to solve a given system of linear equations, 3 equations, 3 variables. All right. Now, the immediate problem we run into here is, how do we solve this for y in terms of just x? We're also going to have a z. And it turns out that the graph of this is going to be a three-dimensional graph. Each one of these equations actually represents a plane in three-dimensional space, kind of like a flat sheet of paper that extends in all directions infinitely and has some angle to the various axes. We can't graph this on the 83 and 84 plus calculators. So we're going to need a different way to go about solving systems like these. You may have already learned about something called substitution in an earlier course. We're going to look at a couple of elimination methods. Actually, we're going to look at one specific elimination method, and then we're going to look at a completely different way of going about this involving something called matrices, and that's going to be what the rest of this chapter is about.